Hey, welcome back. I hope that you had a great day today. We're going to switch gears just a little bit, and we're going to solve some more exponential equations. And the reason that we can do this now is now we have knowledge about how logs work and the working relationship between exponentials and logs. Because the only way that we solved logs before was to rewrite them in the same base. If they weren't in the same base, we assumed that they could be written in the same base, and we wrote them in the same base. But the fact is that most exponentials cannot be written in the same base, and so we have to use the relationship between logs and exponentials to solve those types of exponential equations. So how do I solve an exponential equation that cannot be written in the same base? Well, we're going to apply a log with the exact same base to both sides. Okay, this stems out of the equality property of equations. That says that whatever I do to one side of the equation, I have to do to the other side of the equation so that my equation looks different, but the value, the equality still holds. Okay, so we could use any base, but the two most convenient bases to use is log base 10 or the natural log base e. And the reason is because they have on our calculators, they have a feature that we can use on our calculators to get decimal approximations to those using those logs. So if I wanted to solve the equation 15 to the 3x power equals 285, it wouldn't take very long to notice that I can't rewrite 285 in base 15, okay? And so my next step is to say, okay, well, I'm going to apply a log to both sides. This first slide, I'm going to apply the log base 10, okay? And then the next slide, I'm going to apply the natural log. If I apply the log base 10 to both sides, that's where this log came from. It's just log base 10 of 15 to the 3x has to equal log base 10 of 285. Now I'm going to apply the properties, and I'm going to take my exponent and I'm going to move it to my coefficient spot. That's the power property. So 3x times log base 15 has to equal log base 285. Now here's where students get confused because they think that log 15 is some, I don't know, variable, uncertainty. You have to understand that that is just a way to write the exact value of log base 10 of 15, okay? It's just a number. It's an irrational number, but it's just a number. So we can divide through by it. We can multiply by it. There's lots. We can treat it just like a number, okay? So what we're going to do is, at this point, we're going to divide both sides by 3 times log base 10 of 15. And when I do that, it's going to cancel out on this side, and I'm going to be left with only x over here. And then I have log base 10 of 285 divided by 3 times log base 10 of 15. Please don't think that this is the quotient rule, because it is not. This is taking the entire log of 285 and dividing it by 3 times the log base 10 of 15. Okay? This next line here shows you the calculator procedure. So I press the LOG button, that gives me log base 10. It gave me an open parenthesis, so I plugged in 285 and I closed it off. Then I hit my division sign, and this is where you have to be careful. We want to divide by the whole thing, 3 times log base 10 of the input 15. So I have to put parentheses around the whole thing, okay? Not just the 15, the input 15 into the log. And then when I do that, it is approximated by 0. Actually, that should be like approximation. Let's change this. Let's do this. It's approximately equal to 0.6958 when I approximate to 4 decimal places. The cool thing is that I didn't have to pick log base 10. I could have picked the natural log base E. And actually, this is the one that I prefer the most because you definitely want to use it if your base is an E, one of your bases is an E, and then it works and there's less writing and it's just more concise. So this is my method of choice. I'm going to apply the natural log to both sides. Again, when I do that, I create this exponent condition here that I can then move forward to the front. That's the power property. So now I have 3 times x times ln 15 is equal to ln of 285. Okay? So remember, just like that was log base 10, the 3 is being multiplied by the x is being multiplied by the natural log base e of 15. That natural log base e of 15 is just a number. So I can divide this side, both sides, by 3 times the natural log of 15. They're just numbers, okay? And then here's my keystroking. I hit the ln button. It gave me an open parenthesis, 285. I closed it off. Divided by, again, you got to put those outer parentheses around, otherwise it'll divide it by 3 and multiply by the natural log of 15. So when we do this calculation, notice that we get the exact same thing. It doesn't matter which base you use as long as you apply the same base to both sides. We wouldn't want to go log base 10 on the left and the natural log on the right. So let's use these and let's do a couple on our own. All right, so I have base 2 raised to the x plus 1 equals base 3. Notice I cannot write them in the same base. So now I'm going to just use the natural log because it is my method of choice. So I have the natural log base e of the input 2 raised to the x plus 1 has to equal the natural log base e of 3. I'm going to apply my power property, and that gives me x plus 1 times the natural log of 2 is equal to the natural log of 3. Now, the easiest thing for me to do is to just divide through by the natural log base e of 2. These cancel, and I get x plus 1 is equal to natural log base e of the number 3 divided by natural log base e of the number 2. Right? Now I'm going to subtract 1 from both sides, so I get x equals natural log 3 over ln of 2 and then minus 1. Notice that I'm going to do my division and then I'm going to subtract off the 1. And when I do that, I get 0.5850 when I round to 4 decimal places. I just hate that. Okay. Number 2, same type of thing. I'm going to apply the natural log to both sides. So I get natural log base e of the input 4 raised to the 2x plus 1 has to equal the natural log base e of 30. And then I'm going to move my power forward. To make it a coefficient. And now I'm going to divide both sides by ln of 4 because I want to solve for x. Then I'm going to subtract 1. And then I'm going to divide both sides by 2. I'm going to write it as a half out here. And then I'm going to put it into my calculator. And I'm going to start with taking ln of 30 and dividing it by ln of 4. And then when I do that, I'm going to to close off that 30 divided by ln of 4, close that off. I'm going to hit enter, and that gives me 2.45344. Now I'm going to subtract off 1, because that's the next thing in the parenthesis, minus 1. That gives me 1.453445298, and then I'm going to divide by 2 or multiply by a half, and I get 0.7267. Okay, so why don't you try the video questions, and then we'll move forward from here. All right. So sometimes it gets a little more complicated, particularly when both sides of your equation or inequality each have a variable. This makes our life a little bit more complicated, and we have to think through it. Look at all of these steps. Okay, so let's try one of these, and then I'll let you do one on your own, and then we'll be done. Oh, no, we won't. Forgot about that. Okay, so let me change back over to my pen, and I have to apply the natural log to both sides. If you wanted to do log, you can do that. So ln of 3 raised to the x plus 5 has to equal ln of 5 raised to the 2x. I'm going to apply my power rule to both sides of my equation, and I get x plus 5 times ln of 3 is equal to 2x times ln of 5. Right? Now notice that I have an x over here and an x over here. So somehow I have to get all my x's to the one side. So first, let's distribute. So I'm going to get x times ln of 3 plus 5 times ln of 3. All I did was distribute. Boom, boom. Equals 2x times ln of 5. Okay. Remember, our goal is to get our x's to the left, so I'm going to move my x term to the left. So I have x ln of 3 minus 2x ln of 5. Plus 5 ln of 3 equals 0. Okay, so I need to get my x's all alone, so I'm going to move my non-x terms. This is an x and this is an x, so those have to stay on the left. So I'm going to get x ln of 3 minus 2x ln of 5 equals negative 5 ln of 3. So what I have to do is I have to factor out an x and an x. So I'm going to pull that out, x, so then I get ln of 3 minus 2 ln of 5 equals negative 5 ln of 3. And now I have to divide both sides by this ln of 3 minus 2 ln of 5. Remember, that's just an exact way of writing an irrational number. So when I divide both sides by it, I get x equals negative 5 ln of 3 all over, and I'm going to put it in parentheses because it's the whole thing, ln 3 minus 2 ln 5. Okay? And then we're going to use our calculator to get a decimal approximation, and we get x is approximately equal to 2.5907. Make sure you can get that, all right, so that you know how to do it for your video question. The last thing that we're going to do is we're going to use the natural base e, but we're going to apply the same thing. Notice how one of my sides has a natural base e in it. Notice that the other side will never be able to be written in natural base e. So what I'm going to do is I'm going to apply the natural log to both sides. These are actually easier because of that natural relationship between ln and e. So I'm going to take the natural log of e raised to the 0.003x equals the natural log of 3. I applied the natural log to both sides. Now I'm going to use my power property, and I'm going to have 0.003x times ln of e is equal to ln of 3. This becomes 1. So now I have x equals ln of 3 over 0.003. ln of e, natural log base e, of the input e equals 1. Okay? So it's just going to be 0.003x times 1. And then I'm going to divide x by 0.03003, and when I get that, I get x is approximately equal to 336.2040. And then the second one, we're going to do basically the same thing. I'm going to apply the natural log to both sides, so I get the natural log base e of the input e raised to the 2x plus 1 is equal to the natural log of 30. And then I'm going to use my power property, so that's 2x plus 1 times the natural log of e equals the natural log of 30. This becomes 1, so they undo each other. So now I have 2x plus 1 equals the natural log of 30. Now I'm going to subtract 1. 2x is equal to the natural log of 30. Make sure you close off that 30 before you subtract the 1. And then we're going to divide by 2. Okay, and then on our calculator, what we get, where am I going to put this? I guess I'm going to squeeze it this way. X is approximately 1.2006. 1.2006. Make sure that you close that 30 off before you subtract 1, otherwise you'll be taking the natural log of 29 instead of 30. And then go ahead and try the video question, and then the daily assignment is listed. Thank you so much for listening.